There are infinite combinations of bugs that can result in account takeovers, and the truth is that we will never be able to test for all of them. So to learn which techniques actually make people money, I studied $1.3 million worth of bug bounty account takeover reports, and I studied them. In this video, I will show you what are the most common ways to take over an account. Enjoy! I will start in reverse order from the least common method that I found to the most common one. And the least common one was clickjacking with only 2 reports. And this is a vulnerability class I had absolutely zero respect some time ago. And I actually gained it when I was covering this back, when I was covering the MetaMask clickjacking, which they're allowed to transfer funds to anyone. So this report is not part of this case study, but it's an excellent example of an actual clickjacking attack with a real serious impact. In this case, here is a nice blog post. There are 3 different write-ups here, which usually is a huge pain for me. It's usually the hardest write-ups to understand when doing this case study. When it's like a mass write-up of a few bugs, there are often details missing and things like that, but this is actually a really good one by Renoir, no idea how to read this. And we had this clickjacking attack where here is a nice visualization. At the end, clickjacking becomes impactful when the victim only has to click a button to confirm some action. In this case, the victim has to confirm changing the email address. I assume that the attacker had a way to somehow fill this, but the victim has to click change email. And obviously, normally they will not do this because they see that it's changing the email to someone else's address. But you can manipulate with transparent iframes and put this with transparency and put this in front so that the user actually sees on the website something that's under this iframe, but this is invisible, and then it's the victim has to click the button, and then this way they change the email of the victim, and they can then change their passwords. Usually for clickjacking proof of concepts, it's enough to just show something, click here. In the real attack, obviously you would have to create some social engineering idea on how to get a user to click something, but it shouldn't be that difficult. And a cookie pop-up or an advertisement pop-up should do the job. So this is the clickjacking. This is the first category. The next vulnerability class is pre-account takeover with 3 reports in the case study. This bug class is a bit controversial because some companies do not reward this vulnerability class. Some people say it shouldn't be rewarded. In my opinion, this is a very good example of a low risk attack with quite a good impact actually, but very unlikely exploitation. And the way the pre-account takeover works is somehow you have to register either a particular username or a particular email, and then when the victim comes to the website and wants to use this website, your accounts kind of get merged. The one way it can happen is if the victim logs in using Facebook, but before you created an account using the email, using victim's unconfirmed email, and then when they log in with Facebook using the same email, your accounts get merged and you still have access using the password to the account that the victim actually uses. So it is not an easy attack to perform, but in my opinion, it's a very good example of a low risk vulnerability that should be rewarded because the impact is there. In this case, we have one report in GitHub, and the way it works is quite interesting because you had to create an account, obviously, and then you had to remove this account. But when you remove the account, your session was still a valid session for an account that doesn't exist, but it was still valid. And later, when someone would create an account with the same username, your session would become the session of the new user. So it sounds like a very unlikely attack, because you not only have to know the username of the victim that will start using npm.js because it was the vulnerable website, but you also have to still keep this session alive. And I'm not sure how long the session is alive, or how can you keep it alive, but it sounds like a really difficult attack to perform. But it was rewarded $4,000 of bounty, so quite a nice reward. Next, we'll step to first bug class that has more reports and has more variety in it. Because when I do these case studies, I always try to maintain a good level, good balance between being too specific and too broad. And sometimes I just have to merge things together. Now we come to direct authentication bypass, which just means that the authentication mechanism was in some way broken. One example of a bug like this is this one. It's a $100,000 bug in Apple, which is a lot, and is actually a super simple bug. Pretty much this is what it is. There is just a request with an email, and in the response there is a token which you can use to log in, and that's pretty much the bug. Unfortunately, the gold of this write-up is hidden behind this path, because probably if it would be a path that's normally used, someone would detect it already, because it's quite a straightforward bug. So it's very interesting. What's this path, and how did the hunter find it? But this is the highest paid report from all this, from the whole case study. I'm not surprised that the impact is absolutely huge. But this is the one. This is another one. It was a common scenario where you could copy the cookie from one application to another, and it would work. This particular report I covered on my channel already. I will link the video in the description. And the way it works is there were two different applications on this using the same machine, and turned out that they used the same secret for signing the cookie or encrypting the cookie or whatever. And you could log in to one website using account from another website, using the session from another website. There was also some SSRFs here, not interesting today. It's interesting for me because it's an attack I don't think I've ever tried to do it. I've never tried to copy a cookie from one application to another, and apparently I should. Here's this absolutely the same situation in Starbucks, where the Singapore website worked in another website, I believe, KU2SEC, whatever it is, worked with Starbucks Singapore. There was also at least one other report where you could copy a cookie from one country website to another. Maybe it was Starbucks as well. I don't remember. Other kinds of bypasses, because there were a lot of bugs like these two types, where you would copy the cookie or you would just get the token, basically. What happened with Apple. There were also some reports where you would somehow break the flow of authentication. So I don't know, there are three steps of three requests of authentication. You would send the second one instead of the first one, or something like this. It was also quite a common situation. But I'm showing you this report to tell you that there is no vulnerability class called response manipulation. There is no vulnerability class response manipulation, and if you use it in write-ups or whatever, please stop. Response manipulation is something you can use to help you detect the vulnerability. But essentially, what happens is usually you do something like this. You change error false to error true, or success false to success true. And the application, the client-side JavaScript in your browser thinks that the request was successful, so it sends the next request, whatever it is. So if you change the response, it's not actually response manipulation, the bug here. The bug is that the next request that gets sent does not have authentication check or authorization check. And this is the vulnerability. It's in the next request that's vulnerable, not the one that you change the response to. So please just stop using response manipulation as a title of the bug. Of course, it's a perfectly valid strategy to look for bugs. Personally, I mostly use this when I'm testing like client-side code for XSS or whatever. Most of the time when there's a situation like this, when I have a flow that has a few different requests, I prefer to first just go through the flow legitimately with my credentials or whatever, and then like send the same request with different cookies or whatever. If that's possible, I would prefer to do this over changing the response and hoping that the client-side JS will do the job for me. But in some situations you have to do this. But remember, it's not actually this request that's vulnerable, it's the next one. And one final type of report that I saw a few times was just insecure session cookie. And in no report I saw an actually advanced cryptographic attack for these cookies. It was usually something very simple. Sometimes it was just an ID, or like in this case, just a very short string that can be brute forced. I didn't find any disclosed report where it would be actually like cryptographically complex stuff breaking the cookie. So when you're testing session ID, when it's long, just assume that you can't modify it. Then prefer to like come up with an application from which you can copy the whole cookie, rather than hoping that you can magically like bypass it. So these are a few types of bugs that I saw a few times that caught my attention, that resulted in direct authentication bypass. Of course, this video is about the free chapter of the case study. The whole case study is a part of a BBRE premium subscription. You can access the whole article there. I also this time included a checklist with things that you should check for when looking for account takeovers. I think it is really nice and really helpful, so make sure to check this out. You also get access to all these reports. So if you want to study them more carefully, or you're looking for a particular exploit in your application you're testing, just open all those reports and find the one relevant to you. In the meanwhile, we'll step to the second most popular way to take over the account, which is SSO takeover, and take a look at what happens here. Take a look. I interviewed Yusuf Samuda a few weeks ago. He's the author of many of these bugs in Facebook, and I knew he has a lot of reports in Facebook, but I had no idea he has that many. Like all the links here that say why it's his bugs in Facebook, and take a look at the bounties. It's absolutely insane. And to be honest, these reports completely skewed all the statistics in this case study. I also did in the premium chapters like a breakthrough of client side, server side vulnerabilities, type of interaction, and average bounties for these different reports just look completely ruined by how many great 40,000 reports Yusuf submitted to Facebook. Of course, I encourage you to listen to the podcast that I've recorded with Yusuf. It was a very interesting one, and he just explained how did this happen. So stepping into concrete examples of reports, the SSO takeover in most cases, if not all cases, means that you can leak the code, the authentication code that's part of the OAuth flow. I will not go into the detail of the whole flow because it deserves a video on its own, and I actually created a video on its own about this very report on your screen right now, which allowed to take over a Facebook account if someone used Gmail to log in. It's quite a complex one, and to be honest, there's no doubt in my mind that Yusuf deserves all these great reports, because none of these reports is straightforward. There are always a few steps, there is always a chain, some magic trick, and here as well we have multiple steps for this attack to work. It's not easy. So in this case, you could just leak the code and take over the account, but this is just the end result. For example, here, take a look at this trick that he used. Here there was a redirect URI, but when he would send redirect URI as an array with the 0th index, it would confuse the server side and client side, and the server would verify a different redirect URI parameter than the client would redirect to, because one of these components considered this to be the redirect URI. There was also normal redirect URI, and there was inconsistency in how do they treat this strange input, which resulted in open redirect, which resulted in quite a typical account takeover. So one of very nice tricks. This also, I think I've never tried in my life. I usually try some type of HTTP parameter pollution, but never this variation. So I will definitely start doing it the next time I'm hunting. Here is another report I really liked. Also, some of these account takeovers happened due to CSRFs in some part of the flow. You could either add your Apple account or your Facebook account to victim's normal account, or do something else. And this happens for various reasons. Usually there is just no CSRF protection. But I really like this attack. It's in GitHub by Teddy Katz. And the way it works is, or rather the reason it works, is that when you would click this button to authorize a user, a request would be sent to the login auth authorize, and this is the way it's defined in short. So you have the route, you have methods that you want to route to this particular controller, and inside the controller you have a code like this, and it should be quite obvious what happens because you only route two methods here. And now you check if request is get, we get to this code. So if it's get, we just serve the authorization page HTML. So nothing happens, no sensitive action is done, nothing is modified. But else, all this flow happens, which should happen when the post is sent here. And it should be straightforward because we have two methods here, get and post. So if it's get, we go here. If it's not get, it should only mean that it's post, but it doesn't mean that it's post because there's also head method. Head method is like a get but without body, and no developers actually actively support the get method unless they absolutely have to. The way frameworks work is they treat head method the same way as they treat get, just the difference is that at the end they drop the body and only send headers, because HTTP head method means that you should only get headers. But this means that when the request is routed here, a head method will always also be routed to this controller, but the head method will not get through this if statement. It will not satisfy this check, so it will land in the else block. And for head method, the CSRF protection is not enabled by default, And in this case, you could just send parameters in the URL as the URL parameters after the question mark, and it worked. I actually used this trick very recently. Actually, maybe most of you don't know about it because I don't speak about it very often, but I play CTFs in Just Cut the Fish team. And recently we organized our CTF. I created one task and I used this very trick to, as not the whole task, as half of the task. I actually had a different idea about the task, and last minute I had to change it because I saw too many unintended solutions. And I was actually doing this case study and I saw this report and I thought that this is a great thing to introduce in the challenge. I will link the challenge in the description because the source code of the challenge is available or will be available, so you can try and solve it. As much as I saw loads of OAuth reports, there was only one single report with SAML. I only saw this one from Uber from 2017, where it would be the most basic SAML attack, where just the assertion wouldn't be verified, so you can pretty much send anything there. I was really surprised by this because I thought that there will be, I knew that there will be more OAuth vulnerabilities than SAML, but I had no idea the difference will be that huge, and it really is the only one that I found, which is very surprising to me. And if you're a developer, if you're watching this as a developer, maybe think about using SAML because apparently it is easier to implement than OAuth. And here it's like the more typical vulnerability for 2023, because no longer the redirect URI seems to be vulnerable to open redirect, when you can just put the attacker's URL or burp collaborator URL and leak the code this way. But often, like in the Yusuf's report to Facebook with Gmail, like in the famous blog post by Franz Rosen, you can still somehow control at least the path of the request. Like in this case, this is a report from 2023. You don't have a full open redirect to just send the code to you, but there is path traversal, which allows you to make the code be sent to another website within the target website, and then in this case using Google Analytics, you had the way to exfiltrate the code. And this is like the modern way of account takeovers, and this is very prevalent. And now, with that said, let's go to the most common way to take over account, which was to change victim's password. It was the most common. However, the average bounty is much lower, but this is in big part due to the amount of Facebook reports. The intuition would tell me this will be the more impactful one, because usually this does not require user interaction, and because these are mostly server-side attacks, and in the OAuth takeover you always need the interaction, so it's always a little bit lower severity. Here a very common attack that I saw in this category had to do with OTP codes, and actually a very simple, I would even say almost a naive attack would be to just brute force the OTP codes. In this case, we have 50,000 bounty to Microsoft, and the hunter was just able to brute force 7-digit code. Usually these are not as naive brute forces from a single IP address. Usually these involve renting multiple cloud computing instances to attack the server from different IP addresses. And often hunters just include some estimations or some calculations of how many codes they can predict in what time. It also depends on the lifespan of the OTP code. but there were a lot of bugs like this. There was also Instagram. I think it was one of these attacks which I saw big companies making mistakes. The OTP codes were in a lot of situations. There were also very interesting reports like this one. I also covered it on my channel very early, so if you watch this video, it will probably be much lower quality. But it was also some kind of strange order of signing up, changing the email, having some race conditions in the timing of where is the password reset link sent or whatever. In this case, you had to change the email and send the I think confirmation email in the correct time, and you could take over the account. It's a report by Ron Chan. I actually miss the guy because he's not hunting anymore, and I loved his reports. So Ron, if you're watching this, please come back to hunting, because I need your reports to have interesting videos. There were also simpler bugs, but these often happened in lower bounty. These usually had lower bounties, which meant they were in smaller applications. Here we have Avatar, whatever this is. I have no idea what Avatar is, and just this is the attack. Just the password reset request has new password, has no old password, and has an email. So it's like very straightforward thing to do to just change the email to the victim, and it worked. And there were a lot of reports like this, but often or always it wasn't big companies. It was, even though the attack has great impact because it just allows you to take over anyone's account instantly without the interaction, these weren't often super high bounties. In this case, it's 4,500, which is which is actually quite good. But there were a lot, like $1,500 for these reports. Another thing that was present a few times was AWS Cognito. On the CTF, I've mentioned my friend had a task with Cognito. I will also link this. I'm not sure if this is online or not, but you can at least see the source code. This allows the developer to like outsource the authentication to the service from Amazon, and you can also interact with Cognito using AWS CLI, which can be a really nice attack. And the last type of vulnerabilities which I want to talk about is host header poisoning. This is also very much related to changing the email, because in the case study I say that the way to take over account is to change victim's password, but some of these attacks actually resulted in changing the email or changing the phone number, and only then the attacker would have to reset the password from there. So it was not always directly connected functionalities to password reset, but they resulted in password reset. As I've said, the next chapter of the case study was about the root cause of the bug, where I dig deep into what was the actual reason for the bug to happen. And the way I wrote it is as a checklist for things to check. So if you are a member of VBR Premium, check this out. But in this report, as I've mentioned, this is very much related to the password reset functionality, because the way it works is you change the value of the host header, and then the password reset link has your malicious host in the link. To me personally, this is the attack I think I would barely reward, or I would reward really low, because it requires the victim to click this link even though they didn't reset the password, and not notice the domain, which I think is even less likely than the pre-account takeover scenario. But it works, and here it was rewarded $2,000. If you enjoyed this one chapter of the case study, I guarantee that you will learn much more when you finally join BBR Premium and get access to the full article, the checklist, and the database of those reports. In the meantime, if you want to listen to our podcast with Yusuf Semuda, it's on your screen at the moment. For now, thank you for watching and goodbye.